Very good morning, all. So, I am Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering. I am giving this lecture on numerical radiation, how to solve a problem in radiation under the course of Heat and Mass Transfer for third year BE Mechanical Engineering students. So, let's recall what is radiation. We know that without any medium, if it happens, transfer of heat happens with the electromagnetic wave, that is called as radiation. So transmission and irradiation we know if it transfers, the heat transfers in a medium, that is transmission, and if it irradiates, that is called as irradiation. So coming to the topics for discussion, these are the topics we are going to discuss: basic radiation equation, engineering applications, steps for solving radiation numerical problem, common mistakes while solving radiation numericals, summary and learning outcomes. So basic radiation equation, which is nothing but heat transfer, which is equal to sigma A T1 power 4 minus T2 power within bracket. Here we know Q is heat transfer rate, watts, and sigma is Boltzmann constant, and A is the area, T is absolute temperature in Kelvin. So coming to the engineering application. So applications of heat transfer in engineering: boilers, combustion chambers. So power generation and industrial combustion having application. In case of furnace, industrial heating and metallurgy analysis. In case of heat exchanger, HVAC system, chemical process. These are heat exchangers. So in case of solar collectors, solar power and water heating. So in case of spectral thermal system, temperature regulation and component protection is the spectral thermal system analysis under the concept of heat transfer application. So let me see the another concept about the steps for solving radiation numerical problem. Step 1. Read the problem carefully. Note down the data as given in the problem. Step 2. Convert temperature to Kelvin. Temperature of Kelvin minus temperature degree centigrade plus 273 will give temperature in Kelvin. And select proper radiation equation for black body Q minus sigma A T1 power 4 minus T2 power 4. So for gray body, Q equal to emissivity of sigma A T1 power 4 T2 minus 4 based on the design thinking empathy process, which we have seen already, the basic heat transfer equation. Step 4, substitute the values. Insert all numerical values carefully. Step 5, solve and write units. So writing the unit is very important factor. When we give value in joules per second, that is watts, so always we should follow the same unit throughout the problem. The temperature, in case of temperature, if they give centigrade, one value if you solve in centigrade, one value if you solve with Kelvin, you may not attain the proper application of the value and proper unit. Similarly, for all the cases, we should always apply the same unit for all the throughout the problem with same unit. Even if you apply centigrade, no issue. For all the cases, you have to apply the same centigrade and continue and complete the problem with the unit what we have initially given as centigrade. Coming to the common mistakes while solving the radiation numerical. It's a very important key, we should note it. So using Celsius instead of Kelvin, just we discussed. So when we use Kelvin, we should use throughout the problem Kelvin. So forgetting emissivity, gray body problem requires emissivity term. So that should be submitted as per the formula of general heat transfer radiation. Area should be in meter square, not in millimeter or not in centimeter, something like that. If you should follow the same unit, or at least at the end, you should convert that into meter square. We should see whatever the data what we are supplying here. So incorrect power calculation. The power has to be T power 4. It should be T power 4, fourth power. So that should be meticulously followed by the problem solvers. So using wrong Stefan Boltzmann constant, the value is 5.67 10 power minus 8 watts per meter squared Kelvin power minus 4, which is very easily rememberable: 5678. 5678. So this is the common mistake people doing while solving the problem. This should be avoided. Let we go for the summary and learning outcome. So electromagnetic wave radiation heat transfer occurs through electromagnetic waves only. So Stefan Boltzmann law, which says numerical problem mainly use Stefan Boltzmann law. So temperature influence heat transfer increases rapidly with temperature only. And graphical method help visualize emissive power variation. So coming to the concept of assessment question on this topic, let me see one by one. In radiation heat transfer calculation, temperature must always be expressed in, you know that already we had seen this, in Kelvin. So which surface emits the maximum possible thermal radiation at given temperature, that we know, which is a black body. So with this, I conclude the session with the reference what we have noticed, and I thank everyone for listening my session. And you can post any query related to the concept of problem solving in radiation, and that will be addressed in the text session or query session. So once again, I thank everyone for watching my video on problem solving technique in radiation problems. So thank you very much and all for listening my video.